Good day to you all. In this video we are going to watch at charging of a capacitor from the outside. It is based on a circuit that somebody showed me in a Zilano document. So we have an AC capacitor where we bring our high voltage signal to the outside of the cap, and then we are charging the capacitor itself with an Avramenko plug from earth ground. Now, first we are going to start with looking at the circuit when there is not an extra connection made to the capacitor to see what resonant frequency is and how much current we are using. So if we look at the setup, this coil is my tank circuit. I have powered the circuit with a battery because I don't want any ground connection problems from the power supply to give false measurements. And then over here I have the capacitor. It's not connected now, it's loose. And behind here we have the gate driver that is controlling the series tank circuit. I have two meters. This one is for voltage output and this one is for current that we draw in. Now you can see by the wire is loose over here, we still have a voltage, so I will discharge it. I will keep it low. So now we are going to change the frequency to have best result. So you can see at 956 kilohertz in this case, and 344 milliamps. So I changed the values on the paper for my measurements over here, but as you can see it was approximately as before. Now we are going to go to the second step, and that is by adding the capacitor without a diode in between. So you see we lose resonance. We are now in a situation of this one. I had a false measurement because it was with the diodes, so we are going to do that away. So now we are in this situation where we don't have a diode from the output of our series tank circuit to the capacitor. You see we draw 20 milliamps, but we are completely out of resonance. So I have to lower frequency. As you can see, we don't have much signal. So I'm going to change the setting of my scope so that we have a more clear sine wave. So that's approximately the value that we have. So going to lose the connection. Oh, I have to see. Okay, that's approximately the resonance. The output LED was still connected, so therefore we had a change. So you can see our capacitor is at 400 volts and we are drawing 70 milliamps. So the frequency is now 866 kilohertz. We are drawing 74 milliamps. And the output of the waveform is 59. Let's take 59 volts. So the wave you see over here, but keep in mind I had changed the settings of the scope value lower. So therefore we only have 60 volts approximately at our, and it is measured capacitively, so it's not a real voltage. That's the reason why we can go to 440 volts over here. There is no direct connection with the scope and the resonant tank circuit to exclude influence as much as possible, although there will be. So this is the situation that we have in this case. Now, when I discharge the capacitor, am I going to keep focus on the screen? When I discharge the capacitor, you see that we completely lose resonance directly. Then it has to build up again for the capacitor to charge up. So I will discharge it again, and you see it's completely go away, and we have to rebuild. So what we are now going to do is we are going to add a diode in between. So we have our series tank circuit, and we are going to place this diode in between the capacitor that we are charging from the outside, and then we are going to look at what happens. So going to there, first disconnect, empty the capacitor, do it this way. So we start with an empty capacitor. We see that we don't have resonance anymore, so we have to retune. Now I have to go to the higher setting again. So now we have voltage on the capacitor. So now we are drawing 280 milliamps, probably changing due to the charging of the capacitor. So 318 milliamps. The frequency is 934 kilohertz, and amplitude is around 160. I'm going to see if I can get there. No, that's maximum. 178 volts. And our capacitor is charged to 274 volts. But now when discharging the capacitor, we have much less influence on our circuit. So there are some differences. One is we draw approximately the same current than without that capacitor connected. But in comparison with the voltage output, you can see that we now can only go to 227 volts. So the voltage is not going that high as without the diode. But we have less influence when we discharge our capacitor, because we have still some resonance. As you can see over there, the sine wave shrinks, but it's not completely gone. Of course, I also draw now more current than without that diode. So there are some interesting things in both cases, as we could see. So in this case, we have less influence if we discharge the capacitor, but in that case we have a much higher voltage. but the diode in between has its advantage if we don't want to have much influence to our resonance of our tank circuit over here. So at the moment I don't know what is best, but I want to share this information. If you know other things that I can do to have less influence and have the advantage of less current, like here, because this situation, although it gives the highest output on the capacitor voltage, I cannot really use it because once I use it I always lose the resonance over here. While in this case it is not that, but as you can see, over here we draw 75 milliamps and over there we draw 320 milliamps. And as we can see, that's not that much difference, the 1 and 3, if we look at the maximum current that we are drawing. But this situation for the capacitor is the most interesting because I can go to 400 volts, as you could see, while this is only 220 volts. I also tried with adding an extra capacitor, also with the diode, in reverse direction than this one, but it has its influence on the circuit. So this was the best result I could get out of it in this situation. So thank you for watching and hope to see you in the next video.